Hi guys, I hope you're having a great day. Today, I would like you to take a look at Newton's second law. You're going to write these down in your notebook and you are going to write two column notes. If you don't like to write in your notebook, you may turn it in a Notability. The only deal is I got to be able to see Notability. And some of you have been turning it in and I've not been able to see it. So if you're struggling with that and you're one of those people, use your notebook, please, for these two column notes. Okay, on the left-hand side, you're writing what is Newton's second law of motion. On the right-hand side, you're going to write what I show you. And let's get started so I can show you what that is. So today, Newton's second law of motion, and here it is. It says, the greater the mass of an object, the more force it will take to accelerate the object. So to calculate force, you're going to multiply the mass by the acceleration, which is F equals m times a. The m is mass, the a is acceleration. And if you take a look at that grocery cart, one of my favorite things to do is to grocery shop. I love grocery shopping at Aldi. I get such yummy food. So tell me how this law can relate to an empty grocery cart versus a full grocery cart. So what would be harder to push? An empty grocery cart or a full grocery cart? If you said a full grocery cart, you'd be correct. Because when the cart is empty, it has low mass, so it's easier to push. When the cart's full of groceries, you're going to need more force to move it. So I would like you to write on the right-hand side, the definition at the very top, the greater the mass of an object, the more force it will take to accelerate the object. To calculate the force, you can multiply the mass by acceleration. Feel free to pause it too. Your example would be an empty grocery cart has low mass and it's easier to push. I would like you to write that down as an example. I'll be looking for that. The next slide, talking about position, distance, and direction, and you also see a cardinal symbol there, N-E-W-S, and I learned it news. That's how I remembered it for north, east, south, and west, but we'll talk about that. So each one of these position, distance, and direction has a definition I'd like you to know, and I'd like you to record and write down on the right-hand side. Position is the location of an object. Distance is the amount of space between two objects. And the very last one is direction. It's the course that something moves along. I'm sure there's fun ways for you to remember how to remember the cardinal directions of north, east, west, and south. Here's a couple of them. Never eat soggy Wheaties. Never eat smelly worms. Never eat sour watermelon. On the right-hand side, right next to position, distance, and direction, I would like you to tell me your way of remembering the cardinal directions. If you don't have one, you can choose one of mine on the right-hand side. Feel free to pause and write one of those down, and also record position, distance, and direction on the right-hand side with your definitions. The next one, motion time graphs. Motion time graphs are very easy to see if something has moved, if it hasn't moved, if it's slowed down its movement, or how fast it went. So the first graph that I want to see in your notebook would be a no motion. That's just a plain old straight line. The next one is constant speed. So something's accelerating at speed. It continues, and it doesn't stop. That's constant speed. The very next one is acceleration. So as you can see, something started moving and it started slow and then it really took off. And the very last one is deceleration, which means something started moving really fast and then eventually over time it slowed down. So I'd like to see each of these little mini pictures with the labels, I guess, no motion, constant speed, acceleration, and deceleration in your notebook. Feel free to pause. And the very last, I guess we have one more slide right after this. This is mass and its effect on motion. So if you look at the graph, it kind of explains what happens when the force increases. So we got slingshot. We've got the amount of force for the first slingshot, which is 5 newtons. That's what N means. We've got the measure of speed, 1 foot per second, and the distance traveled is 2 feet. We've got another slingshot. And if you don't know what a slingshot is, there's one in the lower right-hand corner. We've got slingshot 2. We've got 50 newtons, we've got 10 feet per second, and then we've got 20 feet. That's a little bit more. And then look at the final one, slingshot 3. It's got an amount of force of 100 newtons. That is a strong slingshot. And it went about 100 feet per second, which traveled 200 feet. So when the force increases, the speed increases, and the distance it travels increases. I'd like you to write that down. And then you can write a little slingshot there. And then you can also put a little star by this and say the greater the force, the greater the acceleration there will be. The very last slide. Take a look at my toy sailboat. That's the tiny one. And the real sailboat. That's the big one. Which one would be harder to move? Yeah, The real sailboat, it's about the size of your car. Of course, it's going to be harder to move than one that you'd put in the bathtub. So look at the real sailboat is harder to move. And why is it harder to move? We've learned this. It's because it has more mass than the toy sailboat. So the larger the mass, the more force that is needed to move it. When you're recording this in your 2-column notes, I'd like you to draw a picture of a toy sailboat and a real sailboat. And I want you to tell me why the real sailboat would be harder to move. And you will say, because it has more mass than the toy sailboat. Now, when you're taking notes on your 2-column notes, I want you to keep in mind, I am looking for notes that I can read. If you're struggling with submitting things in Notability, please, please, please try to fit everything on one notebook page. At the end of this, I would like you to write a 3-sentence summary telling me what you learned about the second law. And it's really important that I can read your work and I can see your pictures. And again, if you're struggling with Notability, I put a document in your folder that tells you exactly how to submit the work in Notability. You wouldn't use a Google Doc for 2-column notes, not for this today. Okay? Have a great day. I look forward to seeing your notes.